We'll now be connecting to our presentation From Lemons to Lemonade, Creating Sustainable Trails with Mike Ryder, President of Trail Design Specialist. Let me introduce Mike. He's been involved in the design and building of trails since his boyhood, learning about the impacts of people and nature on trails. He became the first trails coordinator at the 1996 Olympic mountain bike race facility, rebuilding the battered course with the help of SORBA, or Southern Off-Road Bicycle Association, and working to resolve several design flaws. In '97, IMBA, the International Mountain Biking Association, approached him about starting a trails education program to teach a better way of designing and using trails. In '99, he started his own trail consulting business, also being hired as Georgia's Trails Education Specialist through a recreational trails program grant put together by SORBA. Mike has developed a high level of expertise in designing and building in the most challenging of terrain, and has put that knowledge to good use in the design of trails everywhere.
Thank you, Denise. I really appreciate that introduction, and thanks everybody for joining us tonight. I'm going to spend a little bit of time talking about sustainable trails, and especially in high-use areas. All right, I'm going to start out by trying to convey an understanding of impacts. Anytime you get into a situation where you're dealing with any problems on a trail, whether it's a new design issue, whether it's an existing trail, or something that you're trying to fix on a trail, understanding the impacts and looking at it from that perspective is really going to help make a difference on the choices you make to solve those problems. We'll start out by looking at what we call natural impacts. This is three things that actually cause erosion: wind, water, and gravity. And if you think about that, when it rains on the side of a hill, water runs down the side of the hill. If it gets on the trail and the trail is poorly designed, then the water is going to run down the trail. At that point, it's going to start removing material and depositing it at the bottom of the hill, just like you see in the slide. Just right here, if you can see my cursor moving around there. In areas out west where they've got a lot of open areas, not many trees, wind actually becomes a very big issue in dealing with removing materials off of a trail. So you get softer soils, maybe soils that have been disturbed by a lot of use or something. A strong wind comes up, and all of a sudden all that soil blows away. And then, of course, gravity plays a part in it. And it can pull material to the side of the trail or off the edge of the trail, down a hill. Bottom line is that if you take us out of the picture, it's going to take a combination of these three things to actually remove soils from the trail. In having us on the trails, the only way, if you took these things out of the picture, the only way materials would be removed from the trail would be on the bottom of our horses' hooves, on bicycle tires, or hikers' boots. So erosion is caused by wind, water, and gravity. This is known as natural impact. On the other side of the coin, we have what is known as user impacts. And these are the issues that we create on trails when we go out and use them. Excuse me. Riding or walking on wet trails and walking around obstacles are two of the biggest impacts that horses have. If you look behind you and you see a clearly defined set of tracks that are being left from your horse in the form of what I call post holing, then you're having a negative impact on that trail. When it rains, those post holes will fill up with water. The rest of the trail will dry out after the rain, and those small holes will continue to sit there wet. Somebody else comes down the trail, steps on those holes or steps on the edge of them, the holes get bigger and bigger, and you can actually end up with a picture like what you see on the screen right here with all of this mud going on there. Most of the time when I've been on horseback on something like this, the horse isn't real keen about walking right through the middle of the mud. So they tend to try to walk off to the side and the impact that that causes is a widening of the trail. So not only does the problem exist on the original trail, but it gets wider and wider and wider as the impact problem grows. So these are our two main types of impact. We've got natural impact in the form of wind, water, and gravity, and user impact in the form of us walking or riding on trails, or riding on the trails when they're soft, loosening up materials, post holing, or going around obstacles. Another issue that we commonly run into is what's known as poor trail design. And the biggest problem in that line of issues are what's known as fall line trails. And if you look at this issue right here on the screen, we've got a trail that's running right down the fall line, and you can see how badly trenched it is. When people go out to try to do maintenance on this kind of stuff, they try to put in structures to drain the water off. The problem is if your trail runs straight down the hill, even if you put a structure in to try to drain it off, the water's going to run around the end and just get right back on the trail. Now, anytime you put in a structure like that, the only thing it tries to do is deal with the natural impact. It's trying to get the water off the trail, which is washing out the material that's been loosened up by users. However, when you bring user impact into the picture and start thinking about how you or your horse are going to react to that particular structure, like a water bar or something like that, then all of a sudden you understand how or why structures like this don't work. People go around them. Maybe it's on a steeper grade and a horse is going up it or going down it, catches a hoof on it and levers it out of the ground. Maybe the type of structure will startle your horse and your horse won't go over it, so they go around it. So there can be a lot of issues associated with trying to deal with a structure like this that in the end, when your trail's running straight down the hill, isn't going to work anyway. So you're out there spending a lot of time trying to maintain this when what is essentially considered an unmaintainable grade. By changing the design or changing the way that we think about trails and placing them on the contour, all of a sudden everything changes. Now, when the rains and the water runs down the hill, when it encounters our trail, it's going to start and cross the trail at nearly right angles. As the water runs down the hill and encounters the trail, it doesn't build any more volume or velocity than it had before it encountered the trail. Since it's not running down the trail, it's not going to remove any of the materials that have been loosened up by anybody using the trail. So essentially, what's going on at this point is our trail is not eroding any faster than the hillside around it. All right. Those of you that do maintenance on trails or are interested in doing maintenance on trails, this type of design really takes a lot of work out of the trails. If you're not having to try to manage water or natural impact on your trails, it really cuts down on a lot of the maintenance. The trails end up laying a lot more naturally on the land. And the really neat thing about that is the trails tend to be a lot more aesthetic. If you really think about it, how often do you see perfectly straight lines in nature? I imagine it's not too often. So if your trail runs in a straight line, then it ends up being fairly unnatural. And that's what you end up with a lot of times when you have trails on the fall line. Take that same trail, put it on the contour. Now it's following the natural curves and undulations of the landscape that it crosses and sits a lot more naturally on the property. Okay, we're going to continue on into a little bit of trail design, and what I really want to talk about here are the rules and get into the rules of the trail. And what I've done here is created a slide that shows the first rule. Now, people may wonder where these rules came from, and when I worked for the International Mountain Bicycling Association, we were fortunate enough to travel the entire United States and 7 different countries in Europe. And it was really quite an education. You know, when we went out the first year, I had really learned a lot about soil types and how to deal with soils and problems that we have here in the Southeast. I'm from Georgia. This is where we do most of the work on our trails. But you can imagine when I got out to, say, coastal California, Utah, the Pacific Northwest, places like that, we're not in Georgia anymore. It becomes a completely different scenario, and the ways to deal with the problems were completely different. So I really listened when I was in these places that I was unfamiliar with, and there were, everywhere we went, there were people that were just like us that had figured out how to deal with their particular situations in their particular soil types, rainfall amounts, different types of use, different amounts of use. And the funny thing is as we traveled around, we really started to learn or hear some of the same things repeated over and over. And it didn't take too long before we realized that these are literally a set of rules that govern how trails are built, or what makes them sustainable and what makes them fall apart. So going back to the slide here, I'm going to start out talking about the 50% rule. And when I first came up with this theory, it was a little confusing to me too, because there's a lot of different angles involved here. But I'm going to try to explain it as simply as I can, which is the way I understand most things. But what it means is the grade of the trail itself has to stay at half or less of what the actual hillside measures looking straight down the fall line. Remember, I was talking just a few minutes ago about fall line trails, and I probably should have taken the time at that point to explain that a fall line trail means straight down the hill. Essentially, if you, for example, if you had a hill that had no features on it whatsoever, it was perfectly smooth, almost like a road going straight down a hill, and you were to drop a bowling ball at the top of that hill, it would roll down the path of least resistance, which is straight down the hill. That's how gravity is going to pull it. That's what's known as the fall line. So looking straight down the fall line, our trail grade has to stay at half of that. Okay? What that's going to accomplish is it's going to allow the water to cross our trail at nearly right angles. So that's what's going to keep it from building that volume and velocity, maintain that sheeting action, and not wash out our trail or even remove the material that was loosened up by people using it. Here's a good example on the screen itself. Here we have a 40% fall line grade. So if we look straight down the hill, it's 40%. The trail itself is running at a 10% grade. Half of 40% is 20%. Our trail is well under that half mark, and so that's going to ensure that when water runs down that hill, it's not going to run down our trail, and therefore our trail is not going to wash out. So it's going to be sustainable. The other side of the coin, where I've got a similar trail drawn on the right-hand side of the screen, shows that same 40% fall line, but now our trail is running at a 25% grade, which is a little bit more than half of our hillside. All right, and here's where we start to get into trouble. Now, as the water runs down the hillside, it's going to get on our trail. And because that trail is the path of least resistance 4 ways, water's going to start to run down that trail. As it starts to run down that smooth trail or that compacted trail tread, it's going to build volume and velocity and start to loosen up or remove that material that's been loosened up by users. This is the point when most people will start putting in water bars when their trail's breaking the 50% rule. Now at least you have some place to drain the water to. But even at that point, basically what's happening is your trail design is wrong. You've broken the 50% rule, and now you're paying the price in increased trail maintenance. Okay, so I hope that that makes sense to everybody. Keep in mind the 50% rule deals with our natural impact. This is what is going to keep the water off of the trail. Okay, now from a user impact standpoint, we have to look at the overall average grade of our trails. And here I've drawn out a little sliding scale, if you will, that kind of shows what you should look at as the maximum grade for your trail in decent soil types. And what I'm talking about decent soil types are clay-based soils or heavier soils. If your soil has rock in it, that's a bonus. That makes it even better. So that's where this scale is. So if you have a trail that is going to exist in a high-use urban area, and this is where, you know, people are using the trail every single day in large amounts, weekends, you know, the parking lot is completely full, and you've got a tremendous amount of use on your trail. We're looking at maximum average grades. Now, keep in mind, I'm saying average here. In other words, that doesn't mean your trail can't go over a 3 or a 5% grade. That means if you had 5 sections of the trail that were at 4% and 2 or 3 sections of the trail that were at 8%, and then it went back to 2%, when all this averages out, then you end up with one of these numbers or somewhere along this sliding scale. So it's an average grade. Mother Nature isn't going to let you just lock onto one grade and go forward with your trail. You're going to run into a tree, you're going to run into a rock outcrop, or something along those lines. So it becomes an average grade. So 3 to 5% on your high-use urban trails. As you get more into the lower-use backcountry areas, your national forests, maybe some of the wilderness areas and stuff like that, that average grade can come up and get steeper. So you can work all the way up to a 10% overall average grade. So it wouldn't be uncommon in a backcountry area or a lower use area to find some sections of trail that might approach 14, 15, maybe even 18% grades to allow people to get around obstacles or to reach an overlook or something like that. But in the end, the average is still going to be somewhere between 8 and 10%. What that does is it allows you to balance between sustainability or low maintenance and natural technical challenge. Okay? Like I said, keep in mind these are average grades. If you're spend enough time working on trails or designing trails or have the opportunity to build trails, then eventually you're going to end up having to make a turn across a hillside. And there's essentially 2 ways that can be accomplished. It can be done with a switchback, or it can be done with a climbing turn. Now, the turn that you see in the photo here is what's known as a climbing turn. A climbing turn and a switchback are similar in the fact that they both usually make about 180-degree change in direction on a common hillside. All right, just like you see here, we've got the upper leg coming in over here on the left-hand side. Turn comes around, makes a 180-degree change in direction, and comes around on the lower side. Switchback does the same thing, but it does it in a smaller area, and it does it by modifying the uphill leg and the lower leg into a flat turning platform. The climbing turn, however, which is pictured here, makes that same change in direction by following the existing grade of the hillside. So as the turn crosses the fall line, right through here in the center apex of the turn, water is going to run down your trail for a short section. To manage that and make sure that it doesn't wash out your trail tread, it has to be placed on hillsides or fall lines that measure 7% or less. All right, I hope that makes sense to everybody. If you put it on a steeper side slope, say if you go out there and you find a 10% side slope grade and you really want to make this kind of turn and you go, it'll probably be okay. what happens as soon as you build this turn and water gets on this section right through here, it's going to build volume and velocity and start to wash out your trail. Some of you, I'm sure by now, are starting to get that fall line itself, or straight down the hill, doesn't end up being the culprit. It's the volume and velocity of the water as it runs down that fall line that creates the problem. And so that's exactly what would happen here if you tried to build a turn like this on a grade over 7%. The lower grade on flatter terrain like this is going to limit the volume and velocity of the water as it spends its time crossing that part of the trail that's on the fall line and not wash it out. The other thing that's going to make this trail sustainable is you have to have a 50-foot minimum diameter on the between the incoming leg. So here's our incoming leg up here, and our outgoing leg down here on the bottom. All right, what that's going to do is it's going to increase the flow of the trail. When I talk about flow, I'm not talking about how the water flows on the trail, but I'm talking about how the trail flows from a user perspective. I know a lot of you are familiar with what's known as knee knocker trails, or trails that are known as tight and twisty, and these type of trails can create some problems. If the trails are too tight or they go on like that for too long, then people start to shortcut across them. This is one of the biggest problems that most people encounter when they're building or trying to maintain switchbacks, is people shortcutting across the turn itself. With the 50-foot diameter on a climbing turn, you don't experience those same issues. There's enough distance between the two legs that people tend to stay on the trail where it's actually easier to go anyway. So this is what's known as a sustainable climbing turn. And just to give you an example of how long something like this can last, this is at the on the Olympic course. Now, this particular turn itself is on the mountain bike trail, but that's at the Georgia International Horse Park. There are certainly horse trails out here as well. This trail comes out of the trailhead. The horses have a separate trailhead, but it's on an old roadbed, and it's really not very interesting. So a lot of the horse folks will get on this section of trail to get out to the main part of their trails. This section of trail was built for the Olympics in 1995. It has existed exactly the way you see it now since that time. The only amount of maintenance that we've had to do on this trail is remove a small berm right over here on the right-hand side where the trail cupped a little bit and was holding water. It took us maybe 15-20 minutes to remove that loose material on the lower edge of that trail. So since 1995, that trail has needed almost no maintenance at all, even though it sees both bicycle and equestrian use. And with its proximity to urban Atlanta, it sees a tremendous amount of use. So it's a really sustainable design. And if you have to make a turn across a hillside and you can find a shallow grade like this to make that turn and have the room, I highly recommend using something like this over a switchback or another structure that that either might fail or cause a lot of maintenance down the road. This is the switchback I was just talking about. You can see, like I said, it has a much tighter turning platform. In this case, an 8-foot turning platform, and it allows people to make turns on hillsides when you don't have that 7% or less, when you've got to make a turn on a steeper grade. Now, what most people do is they end up trying to build too much fill on the downhill leg, just like you see over here. This is the downhill leg. This is the uphill leg over here. They'll start to build this trail or build this turn, and they'll take the material out of this upper leg here, deposit it on the lower leg, and the end result is to try to create a flat turning platform. The arrows that you see on the screen here, these red arrows, indicate the direction of flow. All right, if you notice on the title of this screen, it's called a rolling crown switchback. And, oops, okay, I'm back. It's called a rolling crown switchback. And it gets its name, rolling crown, because the upper leg, once again, going back here, this is our upper leg, is actually insloped. It's leaned back in to the uphill side of the trail so that water will drain off the back side, just like you see right down here. That's what this black arrow is showing, the direction of the water drainage. Okay, so the upper leg is insloped. The lower leg, right out over here, this is the lower leg, is outsloped. And when those two come together in the center of this turn, that's what CL stands for, center line. The center line of this turn, when they come together in the center of that turn, it forms a rolled crown. Okay, so if you look at a switchback, next time you're out on the trail or you're doing maintenance on a trail and you see a switchback out there, if that switchback has grade to it across this turn, then it's not a properly built rolling crown switchback, and now you understand why there might be a big old trench in the middle of it. The whole reason that this upper leg on this turn is insloped, where's my cursor, is insloped is so that you can dig this upper leg down below grade. You'll notice our side slope runs from left to right across the screen, and you can see how this upper leg from where my little measure wheel is all the way down here is actually below the side slope on both sides. Okay, what that allows me to do is, as I dig that down, it minimizes the amount of fill that I have to put in this lower leg. Less fill on a structure like this means less maintenance. Okay, so it's going to make a much more durable structure, and it's going to eliminate that possibility of people shortcutting. To actually shortcut a turn like this, you have to come here, climb up over this edge right here, walk through the woods, come down, drop onto the trail here. I promise you it's much easier to stay on the trail than it is to shortcut a properly built rolling crown switchback. We've built tons of, especially up in the Pisgah National Forest. I guess for a lot of people it might be down in the Pisgah National Forest. And they've held up wonderfully. And without exception, we've had no problems with people trying to shortcut these turns. So it works out really well. But the biggest thing is when you go out to do maintenance on your trail, especially if it has switchbacks in it, take a good hard look at that switchback. If it has grade across the turn itself, then it's actually got a lot of problems. The switchback was not built correctly, and water's running down it. Water should drain in the directions, just like the red arrows show, away from the turn, not across it at any point. So those are two types of turns that you can make on a side slope when you're building your trail or maintaining your trail on the contour. Okay, now we can talk a little bit about trail development. Whenever you're building a trail or maintaining an existing trail, you should always maintain it to what we call a full bench cut construction. Okay, what that means is that your trail is fully cut from this edge on the inside edge to the outside edge. There's no fill material used in this trail at all. What that's going to do is give you a very stable trail tread across the entire width of the trail. So if your horse is walking in the center of the trail, it's just as durable out by the edge or by the inside edge as it is in the center. And so that means that the trail is not going to break down. You're not going to get terraces along the trail tread, or you're not going to have as much of a problem with post holing, and the water will be able to sheet across the trail tread, and your trail will dry out very quickly after a heavy rain event, and so you won't have to wait as long after a heavy rain event, nor will you have nearly as much impact on it. So if you have existing trails that you do maintenance on that were cut a long time ago and maybe the edge was filled in, when you go out to work on them, take a little bit of time and dig that trail in a little bit better and make sure that there's no fill material, that it's benched all the way across, from left to right across the trail tread. And you'll be amazed at the difference it makes to how durable your trail tread is. This is a really good example. This is a section of trail that we built in Bismarck, North Dakota. And you can see it runs around the side of this hill. It's on the contour. And we built this trail one afternoon. And that night, it rained cats and dogs. I think, if I recall right, it dropped something like 6 inches of rain in 4 hours, flooded the streets of Bismarck, knocked the power out. I mean, it was a mess. And the next morning, we showed up out here. We really wanted to see what our trail looked like after that much heavy rain. And that's when we took this picture. The other amazing thing is we walked in from this direction. Notice you don't see big muddy footprints. You don't see the trail tread washed out. You don't see any rivulets where it's cut channels across the trail or anything like that. It was absolutely amazing. And the trail tread was firm and it was moist, but it certainly wasn't what we would consider wet. It was entirely usable the next morning after building it the day before and that much rain. And it really kind of drives home the fact that a trail like this, when it's built and designed correctly, can be extremely sustainable. Oh, and I will add that that grass was incredibly hard to dig through. It was, I didn't think we were ever going to find the bottom of that stuff. So this slide is showing the outslope on the trail tread. And if you think about it, if you take the time to put in a bench cut on your trail tread, okay, that's what that last slide showed, the bench cut. And I guess I should tell you, I'm going to back up for just a second, tell you why we have why it's called a bench cut. If you look at this, especially up in this area right here, you kind of get the profile of it. And if you look at the hillside, the way it existed before we put the trail in, it was a smooth side slope. When we cut in, we cut down and out the entire width of the trail tread. And if you look, it kind of forms a bench. That's where the term bench cut comes from. We trail builders are not an imaginative bunch. So we end up with some pretty generic names sometimes. But it's full bench construction. And so we've got our full bench cut. Now we have to make sure that bench cut is going to drain. And we accomplish that by taking and leaning the trail slightly to the outside edge. So here you see the arrow is pointed from the inside edge of the trail to the outside edge. And what that's going to do is that it's going to allow that water as it runs down this hillside. So here's our fall line right here. It comes to our trail, and instead of sitting on the trail or running along the inside edge, it's going to drain right across the trail and keep on going just like it did before the trail was there. So this is going to allow the trail to be nearly invisible to the rain that's falling on the side of the hill. And once again, here's a good example of that. This picture was taken about 25 minutes or 30 minutes after a heavy rainstorm. You notice that nothing's washed off the trail. The leaves, the pine needles, and everything are still there. And these lighter areas that exist right in these areas right here, that's material that's been loosened up by the people using the trail. It's not been washed away. We maintain a 3 to 5% outslope on our trail treads. So it's just enough lean that the water will drain across the trail tread and continue on down the hill, but it's not so much lean that as our horses walk across the trail tread, they start cutting into the trail tread trying to maintain a level footing. All right, you should not be able to feel the lean if you're standing on the trail. It's very, very, very subtle grade. So 3 to 5% outslope, full bench construction, and If you've got decent clay-based soils without a tremendous amount of sand in it, it'll put together a pretty durable trail tread. All right. Now, a lot of people think that to build a trail that it takes a big machine, like a bulldozer or a backhoe or a big excavator or something like that. And I'm happy to say that we've been building trails professionally for nearly 11 years now, and this is the biggest piece of equipment that I use. This little mini skid steer is made by Ditch Witch, has a little diesel engine in it. You can see me on the machine so you can get an idea of the scale. It's really not a whole lot bigger than a riding lawnmower, but the traction that's provided by the rubber tracks and the variety of attachments that come on these things allow us to be very, very effective at building trails. Just to give you a good example, I typically run a crew of 2 to 3 people per machine on something like this. That crew with just 2 or 3 people and a competent operator on the machine can build on the average anywhere from 300 to 800 feet of trail a day. Now that's not just roughed in, that's cleared, constructed, and finished completely in a single day. So it really makes a big difference on how we build trails. The wonderful thing about it is it can still build narrow, natural surface trails, or what most of us consider single track. We don't have to go in and construct the trails as a road or something like that to accomplish the type of experience that we all enjoy when we're out riding through the woods or riding across a meadow or something like that. So very effective machinery, and it doesn't have to be real big. In some climates or some soil types, especially in coastal areas, you may get into a situation where you just don't have enough binders in the soil. And what I'm talking about when I say binders are clay. You don't have enough clay in the soil, and as soon as you start riding on it, it starts to fall apart. It gets really deep, loose, and it's just really unpleasant to try to use as a trail surface. So we get into a few things that we call trail hardening materials. One of those is that we use is gravel. Now, when I'm talking about putting gravel in a trail, I'm not talking about surfacing it with crush and run like you'd see on a driveway or a gravel road or something like that. If you're going to use rock like this or gravel to harden your trail tread, it has to be mixed in to the soil, and you need to use clean gravel. If you look at the slide here, you can see a really good example of what I'm talking about. This was a horse trail we built just north of Atlanta called Little Mulberry Park. And we got into this section. There was a lot of big seeps in here. It was very wet. You can see the soil back in here, how wet it was. And there we go. And so what we did was we took and put all this gravel down on the trail and then went back over it and mixed it in and then compacted it into the soil. And it created a very, very durable tread that still looked completely natural. All right, it did not look like a gravel trail, but so the rock acted as a subsurface treatment to harden the trail up, so when the horses got on it, they wouldn't post hole it and make a big muddy mess. This works equally well in sandier soils. Another alternative surfacing material that we've used very effectively, especially around stream crossings to harden the banks on either side, are Grassy Pavers. Once again, this is a section trail we did out at the Georgia International Horse Park. We had a crossing here that every time it rained, it would get wet. You can see a little bit of water standing down here. So what we wanted to do was harden up the banks on either side to make sure siltation wasn't an issue and that we weren't continuing to erode this bank as use went up and down it. We put together these Grassy Pavers and kind of graded this out smooth, and then as we finished the back cuts, just like you see over here on this side, we just pulled this loose sand down into the pavers, and packed it down with the hand tools to hold it together. And the really neat thing about that is I wasn't sure if it was going to work the first time we did it. I put the digital level on this and measured the grade. It's a 22% grade coming up out of the stream there. So it's really kind of steep. Traction was not really good. The sand was really soft. You can see how eroded out and bent over the years, and it was really quite a mess. The picture on the right-hand side here shows those same grassy pavers 7 years later. All right, you'll notice that over 7 years, I lost my cursor here. Over 7 years, we lost less than 1/4 inch of material out of the bottom 4 feet of this. That's just loose sand. There was no clay in that at all. It was just loose sand. It's held together. You can see how it's revegetated and growing back in, turned back into a single track trail, and it's held up quite nicely. We've not experienced any problems with it, and since then, I've used it in a bunch of different projects. It's really good when you're backed against a wall and your trail has to go up the fall line for some reason. Not because you don't want to take the time to reroute it, but because maybe there's a property line on one side and a rock outcrop on the other side, or you're coming up out of a stream crossing like we are here, and you need something to harden that grade. This works very well. However, it's not really, it's expensive, okay? On today's prices, each one of these grids has 2.14 square feet in it. Average cost for one of these per square feet now is about $3.60 a square foot. So you're looking right around $7 per paver. So if you start thinking about putting together a large area or a large section of trail, it can get fairly expensive. So we kind of hold those out as a last resort when we don't have any other choices and we have to run up that fall line like you see here and use the pavers. But it is a very effective way to armor a section of tread even on steep grades. While I'm thinking about it, the steepest grade that I've ever effectively used these on is 35% in clay-based soils. And the reason I stopped at 35% is because the trail grade was getting so steep that we felt it made more sense to go to a set of steps beyond that point rather than have people start slipping on it. But they've worked very well in every application I've ever used them on. So I've been really happy with that solution.
Yes, we are going to open up for questions, and I just want to take a moment to introduce our new CEO. But our new CEO is Anna Gibson, and she's on our webinar tonight, and she is going to be taking questions from the audience.
The first question we have on board is, Mike, can you tell us what replanting, if any, you've done on the vertical parts of the bench cut or over the grass pavers?
That is a great question. Actually, I have never replanted a back cut. That's what that section is called on the back side of the upper side of the trail tread. This is the back cut, and the reason we lay the back cut back the way we do is so that it'll revegetate naturally. I've worked with several land agencies who's given us requests to plant the back cuts with grass or winter rye or something like that, and I really resist that temptation because we can get into a situation where we're introducing a non-native species in an area where it doesn't belong. If you blend the back cut back properly, then it will revegetate on its own. I'm going to anticipate another question and say, how far do you blend the back cut back? The easiest way to determine that, because it's all based on soil type, is to look around in the area that you're working in, find the steepest grade that is sustaining vegetation. Measure that grade, and that'll tell you right there what that soil type will sustain, and that's how far you have to blend that back cut back. So short answer to your question, no. I don't recommend replanting back cuts. If it's done right, it will revegetate in the season.
Mike, are there any circumstances where you do need to bring in larger equipment than the equipment that you showed there, or do you try to avoid that at all costs?
I try to avoid it at all costs. You know, the bottom line is that we're trying to create an experience, a positive experience for the people that are going to use the trail. And when we get into these situations where we're trying to bring in massive types of equipment, eventually the trails narrow up and everything grows back and it looks better, but it takes a while to do that. And what we found is that we can still effectively and efficiently build trail with the smaller equipment and not have to wait for that regrowth process. We can have it right from the beginning, so there's no waiting. And it's worked out very well for us.
A lot of us are recreational users of trails on federal or other publicly held lands. Can you give us any best practices for approaching the caretakers of those trails about maintenance and improvements to the trails and how we might participate in their upkeep and improvement?
Sure, that's a great question. Whenever I'm working with a group or have an opportunity to educate a group, I really encourage them to take the time to get a solid understanding of sustainable trails, very similar to what we talked about tonight, and approach the land manager for that property or the caretaker for that property with that common sense approach and say, hey, you know, what we're trying to do is we're trying to protect the environment that we utilize as trail users, and by making changes to the trail system or by putting in trails that are sustainable, we're not only are we getting better trails for us to enjoy, but we're actually helping to promote responsible use in this particular environment that the trail runs through.
And you know, on the flip side of that, are there any recommendations you would give as general rules of usage that would help us be better users of the trail?
The number one thing that I always drag my little soapbox out and get on is responsible use in wet weather, in times of wet weather. You know, if you listen to people and what they have to say about the impacts, especially from the equestrian community, besides the whole poop on the trail thing, which we'll let that rest for another day.
Yeah.
Is what they leave behind in the form of footprints and post holing and churning up the trail and that kind of stuff. And a lot of that comes from getting on trails too early in the spring when they're still soft, or going out and purposely riding trails when they're wet and muddy. All you're doing is perpetuating that horses are bad type mentality. So responsible trail use, you know, the hardest thing to do is haul 2 to 4 hours to a trailhead to find out that it's been raining for 2 days straight and the trails are a mess, you know, and your only choice is to get out and ride on the gravel roads or something like that, or go choose another area where it hasn't rained. That's a hard decision to make. But when you make that decision, you've put the equestrian, taking a giant step forward for the equestrian community and their relationship with that particular land manager.
Yvette says that the section of trail with the Grassy Pavers, how long was that section of trail?
That section that I showed on there was 30 feet. The longest section I have done is over 200 feet. Mm-hmm. And everything that I've ever done is always held up.
Okay, and there's a follow-up question to that from Barbara Oslin. She says that, let's see, Mike, have you had feedback on the pavers being too slick for horses' hooves, especially when wet from crossing streams? What's the best way to keep a soil cover anchored?
I'm glad you brought that up, Barb. I forgot to mention that the top edge of the paver, where you would contact it with your horse's hooves, is actually serrated. It's not sharp serrated like it would cut you if you were barefoot, but it's got these raised bumps on it, and the traction on it is exceptional.
That's good. I'm seeing some more of the questions popping up now. It looks like they've been in limbo here for a while. Yvette asked, she was talking about that when you were talking about the rolling grades. Did you build in rolling grades on those sections of trails?
I will comment it on in regard to the Grassy Pavers, and typically no, we don't put grade dips on the areas where we're putting in the Grassy Pavers. Now, on that one I just mentioned that was a lot longer, I did put in a grade dip above it, and I put in a grade dip below it, just as a safety valve, but it really, I don't feel that it was entirely necessary. The beauty of the Grassy Pavers themselves is they hold the material that you put in them together so well that water can literally gush down these things and not create that much of an issue. You know, and like I said in this slide here on the right-hand side, that picture was taken when those pavers, these same pavers, were 7 years old and with just loose sand backfilled in them, and we lost less than a 1/4 inch. Other areas where I've done those same type of grades or more with clay-based soils have shown no wear whatsoever.
Yeah, and I have to say that as a landscape architect, I've done a lot of installation of soil anchoring materials, and it's all tied into the quality of the installation. If they're installed properly, they will work properly for a long time. If they're not, you run into problems almost immediately. So there's an indication of a good installation.
Good point.
Okay, now Becky asked, do the Grassy Pavers in stream crossing situations work if the ground coming out is soft and muddy?
Yes and no.
Yeah.
First off, I have to know how deep soft and muddy is, Becky. In this particular crossing, this was a very soft, sandy bottom. It wasn't muddy, and what my biggest concern was that water through this area right here was going to wash in and get underneath the pavers and wash them out. So what we did was we piled rock, head-sized stone, also known as riprap, in this area just above the pavers, and as the water comes down this drainage and hits this rock, it slows down and the water goes up and over, and that creates an eddy behind them, and so it actually keeps sand piled in on top of the pavers. So instead of washing out, it keeps material actually placed in there, and the water can't get underneath it. I would say if the mud is more than 6 inches deep, these things are probably not going to hold together. There's going to be too much movement for them to stay locked together in one position.
Okay, and Debbie asked, how do you respond to comments that horse trails are expensive versus hiking and biking? And I'm going to make an assumption that they're talking about the initial building as opposed to maintenance.
I smile, first off, and then I look at it as an opportunity to educate. People make the assumption that just because horses are big, they have more impacts, and therefore it takes a lot more work to create a sustainable horse trail. People also work off the assumption that horse trails have to be 8 feet wide because you might have 2 horses passing in another direction. Horses don't take up any more room on a trail than any other user. And people that want to build big, wide horse trails, especially in shared use situations, are creating the potential for conflict, because as soon as your trail gets wide, speed becomes an issue. So I will deal with those comments, especially in those regards, that horse trails don't cost any more than any other trail. The biggest single difference between a horse trail, a bike trail, and a hiking trail is literally the height that you clear the trail to. The trail tread remains the same. Sight lines are important on all three of those. It doesn't have to be big, wide trail. It doesn't have to be armored with anything special. It just has to be managed for horses and cleared a little bit higher.
Okay, next question from Karen. She says, many existing trails are based on prior logging, and then she has in parentheses, read water bars or other types of user trails. What are your recommendations for refurbishing those paths?
Yeah, make them go away.
Yeah.
Logging trails or logging roads, extraction roads, those were designed and built to remove materials from point A to point B in as quickly and efficiently as they possibly could be. All right? When the people that built those roads or trails built them, they weren't thinking, wow, someday these are going to be the best horse trails ever. All right? They're thinking extraction. From a land manager's perspective, after that timber sale or whatever is completed, those roads are supposed to go away. They're never intended to be used for recreational purposes. They are frequently used for recreational purposes because they're easy. They're already there. The impact studies have already been done, and all you got to do is clear them and open them up. That does not mean that they're going to be great trails. Anytime I encounter that kind of stuff, I do a lot of consulting on trails that have been routed on old logging roads and stuff like that, is to put together a multi-year plan that's going to remove the trails from those logging roads, eliminate those maintenance issues with the water bars and everything else that go along with it, and get sustainable trails put in.
Okay, Roy Cornett had a follow-up comment. Actually, he's got two comments here. And he said you might explain that talking about the grassy pavers being slick, he said you might explain on the pavers being too slick for horses' hooves, especially when wet from crossing, is that it supports multi-use non-motorized trails. When all of the user groups have a common vested interest in keeping the trails open and sustainable. And I think that's a very important point. He also says, thanks for providing this program. I had the opportunity of taking Mike Reiter's course several years ago. He continues to do an excellent job of sharing his knowledge and experience willingly to those of us who share his passion for trails. Thank you, Roy, for that comment.
Checks in the mail.
Okay, this is Leon from Forest Service in the Eastern Region, Region 9. Our problem is that the region is trying to fix trails that were improperly made or improperly maintained over 30 to 40 years. We are doing great with new trail construction, but the problem we have is maintaining what is in place. We have problems trying to relocate existing trails and restoring the retired trail. Declining trail budgets prohibit us from doing a lot of relocation. It seems to be more difficult to complete needed maintenance than to construct new trails. Solutions? Sorry for the long question.
Yeah, that's a pretty common problem, and what I have done with the Forest Service in other regions, even in Region 8, is to prioritize the problems. And you know, unfortunately it's not an easy answer. You know, I would love to be able to have a magic trail wand I could wave and just make those kind of problems go away, but it does come down to time and money. Now, the good news is that working with people that can provide permanent solutions, like what we're talking about with contour trails and stuff, means that when you do spend that money, it's only going to be one time. So what I've worked with the Forest Service and other regions is to go through and prioritize their problems, do an assessment on their trails, and say, all right, let's work on getting money to fix this problem first. Once it's done, it goes away, you're not having to spend any more money on it. Then we work on another problem and another problem. And I realize this seems like a never-ending scenario because you have many miles of trail. But over time, it does make a difference. And what I have also seen, that especially down here in the Southeast, is that once that ball starts rolling, it starts out slow, but it actually gains momentum. And I've seen where people will start to take notice that, hey, some of these repairs are permanent and it's working. What can we do to help make more of these happen in a faster timeline?
That's a great answer, Mike. And I think that's something that we always need to keep in mind, is that the Forest Service has a lot of trails that they have to maintain, and that when they close them, it's for a good reason, and when they have to redesign them, it's for a good reason. And of course, all of our volunteer hours that we put in as horse lovers, equestrians, and other trail users are very, very important. Okay, I've got one more question from Debbie. What width of trail is needed for multi-use where horses are met? Tread, clearance, single track?
Multi-lane highways work well. No, if you think about it, 2 horses can pass in roughly a 4-foot area. Is it going to be tight? Absolutely, absolutely. But I really, really frown on building trails really wide, in excess of 4 or 5 feet, on the chance that you're going to constantly run into horses having to pass each other. Once again, if you think about, especially a lot of our national forest trails, you meet other users coming head-on all the time. The nice thing about the narrow trails is it forces an interaction. 9 times out of 10, that interaction is positive, and everybody spends a couple minutes talking and then moves on their way. On wider trails, people tend to pass each other going in the other direction, and they might, throw up a little wave or a quick hello or something like that, but you really miss out on those interactions that can enhance a user experience. Now, that's the tread width. Clearing widths, on the other hand, are a completely different scenario. If I've got, say, a 48-inch wide trail or a 4-foot wide trail, my clearing width is going to be 3 feet on either side of that trail. So I'm going to clear it wider to accommodate that and make things a little bit better or a little bit easier for people to go by. Now, keep in mind, when I say that clearing width is 3 feet on either side of the trail, I'm not talking about clear cutting our corridor. You're going to leave all your trees in excess of 6 inches in diameter. You're taking out understory or shrubbery. You're taking out mid-story, small saplings and stuff like that. You're opening up the sight lines. And when you do that, then that allows the users to move to either edge, the inside edge and the outside edge of the trail, and they can pass comfortably without having to worry about getting, brushed off their horse by a sapling or hit in the face by a limb or something like that. Clearing height is always a minimum of 12 feet.
Okay, I think that's all the questions that we have for this evening. And Mike, I want to thank you very much for that presentation. And I want to thank all of the attendees for attending and for asking a lot of really good questions.